All right, greetings, scholars. We're going to continue our exploration on Chapter 5, Polynomial and Rational Functions, and we're going to be working on Section 5.4, Dividing Polynomials. A few learning objectives. In this section, you will use long division to divide polynomials and use synthetic division to divide polynomials. So when it comes to like polynomial long division, it parallels this. It's parallel to like how we do regular long division, right? So if you think about the steps that we have for long division, polynomial long division is similar, just with a few augmentations. Okay, so the division algorithm. So I kind of want to explain this real quick. So like when we say like one polynomial divided by another, the quotient is usually our remainder. Our answer. The quotient is our answer. This is our remainder. This is the thing that we're dividing by. All right. So if we say this guy divided by this guy, this is the answer, and this is our remainder. All right. So the division algorithm states that given a polynomial dividend, f of x, right, and a non-zero polynomial divisor, where the degree of the divisor is less than or equal to the degree of the dividend, there exists a unique polynomial q, which is our quotient, and r, which is our remainder, such that f of x equals d times q plus r, where q is the quotient, r is the remainder. The remainder is either equal to 0 or has a degree strictly less than the divisor. If the remainder is 0, then the divisor divides evenly into the dividend. This means that in case both the divisor and the quotient, this means in this case, both the divisor and the quotient are factors of the dividend. Okay. So let's kind of go through this real quick. So given a polynomial and a binomial, use long division to divide the polynomial by the binomial. Set up the division problem. Determine the first term of the quotient by dividing the leading term of the dividend by the leading term of the divisor. Multiply the answer by the divisor and write it below the like terms of the dividend. Subtract the bottom binomial from the top binomial. Bring down the next term of the dividend and repeat steps 2 through 5 until the last term of the dividend. If the remainder is non-zero, express as a fraction using the divisor as the denominator. I feel like that's easier to see in action. So we're asked to divide here. Okay, let's see. So we'll put our x plus 1 here. Our dividend is this 5x squared. Let me think. Okay. Plus 3x minus 2. Okay. So then first thing we're going to do, we're going to say the first term divided by the first term. So 5x squared divided by x is going to be 5x. So I'm going to line up my like terms. So 5x. Now on the diagonal, I multiply. So we're going to say 5x times x. All right, 5x times x to give us 5x squared. And then 5x times 1 gives us a 5x. The next step, we subtract the bottom binomial from the top polynomial, right? So we're going to distribute a negative here. Okay. So a number minus itself subtracts to 0. 3 minus 5 is negative 2. So that's a negative 2x. And then this negative 2 comes down. Now we say the first divided by the first. So negative 2x divided by x is negative 2. Right here. On the diagonal, we multiply. Right? So in this direction, we multiply where the purple is. So then negative 2 times x gives us a negative 2x. Negative 2 times 1 gives us a negative 2. And then we distribute a negative there. So these signs change. And then all of these are opposites. So we get that. So this is our quotient, and we don't have a remainder. So we got a quotient of 5x. 5x minus 2. Okay, yeah, this is fine. Okay, so notice with this one, every power is accounted for. Like we don't need any placeholders, let me think. You know, it goes power 3, 2, 1, 0. So we can kind of repeat what we did before. We have our 3x minus 2 divided into 6x cubed plus 11x squared minus 31x plus 15. Okay. So we're going to say the first divided by the first. That's going to be what? 2x squared. Line up our like terms. On the diagonal, we multiply. Right? So we're going to multiply in that direction. 2x, so 2x squared times 3 is going to be what? 6x cubed. 2x squared times a negative 2 is a negative 4x squared. And then we need to distribute our negative. So this becomes negative and this becomes positive. Okay. So number plus its opposite adds to 0. 11 plus 4 is going to be 15x squared. And then the next term comes down. So now we're going to say the first divided by the first again. 15x squared divided by 3x is what? 5x. So plus 5x. Again, along the diagonal where the purple is, we multiply. So 5x times 3x is 15x squared. 5x times a negative 2 is a negative 10x. Then we need to distribute our negative. So this becomes negative, this becomes positive. So number plus its opposite adds to 0. Negative 31 plus 10 is a negative 21. And then the next one comes down. Okay, then we're going to say the first, let me try it again. The first divided by the first again. Negative 21x divided by 3x is what? Negative 7x. Sorry, negative 7, all right? So on the diagonal, we multiply. Negative 21x plus 14. So look, we need to distribute a negative. So this becomes positive, this becomes negative. It looks like we have a remainder of 1. Okay, so one way that we can write the remainder, we could either put r equals 1, or we could say plus 1 over 3x minus 2. Okay. So we got 2x squared plus 5x minus 7. 2x squared plus 5x minus 7 plus 1 over 3x minus 2. That's correct. Okay. All right, so let me give up my own synopsis of synthetic division before we go through this. With synthetic division, it's a shorthand way of doing polynomial long division. I'm under the impression that we can use synthetic division whenever we're dividing by a linear binomial, right? Binomial meaning 2 terms, linear meaning the highest power is 1, right? So synthetic division is a shortcut that can be used when the divisor is a binomial in the form of x minus k, where k is a real number. In synthetic division, only the coefficients are used in the division process. I'll let you read through the how-to on your own. I'm just going to kind of explain it as I go. So notice that we're dividing by a linear binomial, this x minus 3. So then what goes into the chair is the 0 of the linear binomial, right? So if we're dividing by x minus 3, the 0 there will be 3. So 3 goes in the chair. Now we take the coefficient of each term, and sometimes we have to include a placeholder. Like if we skip a power, we have to use a placeholder, but it doesn't look like we skip any powers here. So we're going to take all the coefficients. So then the coefficients are 5, negative 3, and negative 36, okay? We'll leave a little bit of space. Now the first, whenever we go vertical, we add. Whenever we go on a diagonal, we multiply. So the first term, it just comes down. Okay. Now on a diagonal, we multiply. So then 3 times 5 is what? 15. Vertically, we add, so we get 12. Diagonal, we multiply, we get 36. Vertically, we add, and we get a remainder of 0. Okay. So that means 0, 0, our remainder. So then if we started with a degree 2 polynomial, this result is called the depressed equation. It drops by 1 degree. So now this is a degree 1 polynomial. So we have 5x plus 12. Okay. So then the result is just 5x plus 12. It's just 5x plus 12. That's fine. Yeah. Okay. My table's extra noisy today. Use synthetic division, divide this. It doesn't look like we need any placeholders. If we're dividing by x plus 2, that means negative 2 goes in our chair. And our coefficients are 4, 10, negative 6, and negative 20. Notice we started with the degree 3 polynomial and we finished with 4 terms, right? It's four coefficients, right? So again, the first coefficient just comes down. On a diagonal, we multiply, so we get negative 8. Vertically, we add, we get 2. And then what is that? Negative 4, negative 10. Double negative is a positive 20. And we got lucky here again. We got a remainder of 0. Okay. So then if we started with a degree 3 polynomial, our result is going to be a depressed equation. Not that it's sad. It just drops by 1 degree, right? So it's now a degree 2. So we say 4x squared plus 2x minus 10. Okay. Okay. Leave that be. Okay, so here we're asked to use synthetic division. Let me see, 4, 3, 2. Now it looks like we need a placeholder here. It looks like it skips over the power of 1. So again, when we're doing synthetic division, we have to make sure that every power is accounted for. If we're missing a power, we have to use a placeholder, right? So since we're dividing by x minus 1, the 0 there is going to be a 1. So we put 1 in the chair. And we do need a placeholder. So the first coefficient is negative 9. Then we have 10, 7. We need a placeholder here because the power of 1 is missing. And then the constant is negative 6. Okay. And again, the first coefficient just comes down. On a diagonal, we multiply. Vertically, we add, we multiply, we add, we multiply, we add, we multiply, and our remainder looks like it's a 2. Okay. So if we started with a degree 4 polynomial, our depressed equation drops by 1 degree. So this is now a degree 3 polynomial. Okay. So then when the original dividend is divided by that divisor, the result is negative 9x cubed plus x squared plus 8x plus 8. And our remainder is 2 over x minus 1. Okay. Looks like this section is short and sweet. We're just about done. We might have like one more. The volume of a rectangular solid is given by this polynomial. The length of the solid is given by this, and the width is given by this. So then find the height. Okay, rectangular solid. So I don't know why I'm choosing this color. Copy and paste. We'll just work with this. I'll leave it in this little, like if I leave it like this, it kind of shifts where the front face can either be pointed up to the left or kind of down to the right. It kind of flips based on your perspective. You can make it either point up to the left a little bit or it points down to the right, depending on which face you make, the back or the front. It's just tripping. Okay, so we're given that. Nope, don't know. Okay, so we're given that the volume 3x to the 4 minus 3x cubed minus 33x squared plus 54x. Okay. It also says the length. Okay. So it says the length is given by 3x. The width is given by x minus 2. We're asked to find the height. Okay. So volume of an image like this is going to be the length times the width times the height. All right. So here, let's write it like this. We'll do this color. If we have that the volume, nope. So we said what? The length times the width times the height equals the volume. If we want to solve for height, then our height is going to be the volume divided by the length times the width. Okay. So let's go ahead and do the length times the width. So the length times the width (3x squared minus 6x). So then if we want the height, we're going to say the volume divided by that result. It's not a linear binomial, so it doesn't look like we can do synthetic division. I might need some space. Yeah, let me just give myself some space instead of trying to cram it in here. Copy and paste. Okay. So then just take a copy of all of that. Paste. Now let me get rid of what I'm not using. Not using these either. Okay. So we're going to say that divided into that. So this can go about like there. This can go about there. And we're doing like this. All right. So again, we can't do synthetic division here because it's not a linear binomial. It's not in the proper form. Okay, let's do this. So if we're going to do this polynomial long division, we'll say the first divided by the first. So what is that? Just x squared is that result? So we're going to put the x squared here. On a diagonal, we multiply. All right, so in that direction, we're multiplying. X squared times 3x squared is 3x to the 4 minus 6x cubed. Okay, we need to distribute a negative. Okay. A number plus its opposite adds to 0. 6 minus 3 is positive 3. And then this term comes down. Okay. So now we're going to say the first divided by the first again. Okay. So let me see. X cubed divided by x squared is just x, so that result is just x. Oh, we might need a placeholder. I forgot about the placeholder. 4, 3, 2, 1. Let me say plus 0 here. So I think we get x there, so we're going to say plus x. On the diagonal, we multiply. So then what is that? 3x cubed minus 6x squared. Oh no. It looks like it doesn't go evenly. Oh, wait, we're subtracting. So we distribute our negative. A number plus its opposite adds to 0. What is that? Negative 27. And then the next term just comes down. Okay. So then we're saying the first divided by the first again. So we're saying the negative 27x squared divided by 3x squared. 27 divided by 3 is what, negative 9. Okay. On the diagonal, we multiply. Negative 27x squared. $54. We distribute our negative. And I think these add to 0. Okay, I think we're done. Okay. Now let's go back to the question. So we got a height of x squared plus x minus 9. We got that the height equals x squared plus x minus 9. Oh, wait a minute. Oh, let's see. They were able to, let me see. I thought it looked like we could factor out. Let me see. Oh, they did multiple steps. Okay. So, yeah. So what they ended up doing, I guess they felt like it was easier to divide by 3x, right? Because all those were multiples of 3. So they first divided everything by 3x. They got a result. Then they used synthetic division, right? Because what was remaining was that x minus 2, right? That's fine. So at least we have two different ways of doing the same thing. I think we should get the same result. So the height of the solid is x squared plus x minus 9. Yeah, that was good. That was interesting. Okay, and so with that, we're going to end the session here. And from one beautiful mind to another, take care. Peace.